Okay, so here we are. Back again is our lesson for Wednesday, Unit 7, Lesson 10. We're going to share a screen. Okay, so we're in the homework part of Wednesday. And we might be, if there it is, let me share our screen. Okay, so the fact that we have each set of triangles here. So when we look at 10, you wonder, you think, well, I don't know. Why don't they tell us that those sides are parallel? Okay, so they don't tell us that those sides are parallel. So I'm not sure with that, if they had done this, then we'd know for sure that we had similar triangles. I'm not sure if they're saying, well, these must be right angles. They look like right angles. And then you would know for sure, right? Because you'd have two angles equal to this angle in the acute, very acute angle there would be the same. But without it, I'm not sure if you have enough information. So that's one I'm a little surprised at. Whereas in two you see that, right? So you've got the similar triangles here. So you say, okay, I've got these similar triangles. I've got similar triangles. So given that I have similar triangles, I have they aren't necessarily right triangles, but it doesn't matter. So you can just say similar sides would be 7 to 9 is like what? Is like 7 plus 5 to 9 plus question mark. Okay, so you got to work a little bit harder on that, right? Because you don't, well, you just have to add up 7, 5 is 12 to something, right? And then this one, you have a part. So here again, I'm a little disappointed. If they don't put in right triangles there, you don't know. So this is kind of a bogus one as well. But just assume that they're right triangles, and so if they are, then you can figure it out as well. And so there's just that idea that sometimes you don't know the whole side, you have to add it together, right? So you say, well, this is, so you'd say the horizontal, the vertical to the horizontal of the small triangle, and then we have the vertical to the horizontal, but the horizontal, you just have to be careful, is 8 plus 12, right? So to do that one. Okay, so then let's see if we have anything else. Solve using trigonometric ratios and Pythagorean theorem. Okay, so let's say that you wanted to do things like get the, this is something that, maybe you could use Wolfram for this, right? So once you start, you can just plug them in, right? So the sine of A equals, sorry, the cosine of A. Cosine of A equals 17 to 18. Okay, so then you'd say, okay, arc cos, the reverse cos, and just say, well, what degrees is that? And once you know this degrees, right, then you can just subtract from 90 and get the other one, and then you could just say sine of something to 18 with the angle that you got from there, and you could do that. Okay, so give those a try. And then finally, sine of A equals 1/2. And so you think about, well, is there a special triangle? And the special triangle that we have, I think is the one to think about is the 1 square root of 3, 2, right? So it's the ratio of this to this. So, so that's our 30-degree angle as a sine of 1/2. Right, the ratio is going to be 1 to 2 for that 30-degree, 30, 60, 90 guy. Cosine is 3/5. Well, it's a little bit more, right? So then you say, well, what do I have if I'm a 45 degree? So if I'm a 45 degree, I have 1, 1, radical 2. And you might have noticed that that's 0.071 cosine. So what do we have with 3/5? The ratio is 3/5. So we say, well, it's going to be cosine of 3/5. So sine of 3/5 we knew. Cosine of 3/5 it's going to be less, right? So it might be a bigger angle, right? So this is interesting. Yeah, so you're thinking about sine, but you say, okay, if I reduce this side a little bit to make the, no, I want the angle to be bigger than, I want it to be, the ratio to be more than point. Ratio to be not as much. Yeah, so it's actually going to be a bigger angle. So the angle is going to be bigger than 45 degrees. The cosine, yeah. All right, so that's an interesting one. So tangent is 6 to 7. So this is one where you say, okay, 45 degree, yeah, that's not good. Okay, so if I had a 45 degree, I guess I should get get that into the clip art. Okay, so I think there is one there. Okay, so there's one. Okay, so let's say that you got this. So this is tangent of 45, and so if you look at this tangent, right? So tangent of 45 is 1 to 1. Okay, so it's 6/7. So it's going to be smaller. So it's going to be a little bit less, right? So you say, okay, well, what if it was a little bit less, then this would be less than 1. So it might be 6/7 to 1. What I wanted to look at was down here. Okay, so we want to say what's equivalent. Okay, so this is a real useful thing to get. Okay, all of these are really useful, but what is sine of A? So sine of A is A to C, and A to C is the same as cosine of B. Right? Right, so when you do that, you say, okay, sine of angle A is side A over C, but that's the same as cosine of B, which is its adjacent to C. Okay, so you want to find that kind of thing. And then for sine A to sine B, you say, okay, I have A to C, sine it to cosine over cosine of A is B to C. And so you just say, okay, well, that's A to C times the reciprocal. Oh, but A to B is just what? It's just the tangent. So this is an interesting one to look at as well. You know, in looking at these, I think this is this might be might be more than we want to do in a day. So I'm gonna I'll change this into a 2-day assignment, okay, so we can work on it some more.